Thank you. And I'd like to thank Seequent for inviting me to talk here today. I acknowledge that we sit in a very different space in the exploration sort of sector compared to the other two talks so far today, and most of you in the room. And I'm going to be talking a lot about data as well. So before I get into the concepts of fair and open data, I want to talk a bit about where we, the GSQ as an organisation, have been, our past, what we're doing now, and what we're going to be doing for the future, and where we see ourselves as an organisation going. So the GSQ was formed 151 years ago. We celebrated our 150th anniversary last year, and this is going through like crazy. Stop. Good. I'm going to put that down. Sorry. So it was formed after the discovery of gold at Gympie. So this is at the same time that there was the gold rushes going on in Victoria. And over here we have our first government geologist, Richard Daintree, who was tasked with the role of discovering potential for exploration for the entire state of Queensland. They realised quite quickly that was a big job, so they employed a second person, Richard Alpin, to do the southern half of Queensland, while Daintree did the top half of Queensland. And this is just going, sorry, is there a reason that's going through timing? So they were really looking at identifying the major economic locations, gold fields and coal seams of the area. And the early GSQ was really involved in mapping of fields, mapping of potential in areas. Sorry, it seems like I've got timing sitting in the entire thing. So you can see over here, this is Daintree's first map that he created of the Cape York goldfields, and the more recent update of that map coming through. So the goal was really the prospectivity of the state of Queensland. And that role really hasn't changed much over the last 150 years. The purpose hasn't changed much over the last 151 years, but the roles have changed. So some roles have remained the same, some have grown, and some new needs have surfaced. But really, it's been about geological mapping, geophysics, geochemistry, and enabling the exploration industry. So we've gone from being the group that was doing the discovery, doing the exploration, to being the group that was supporting the discovery, supporting the exploration. We've also become the custodian of the data and the reports collected in Queensland, and that's a role that is growing, has been growing for a long time, but is growing exponentially more rapidly now. And we've changed from our point of being nearly a forced curator to being our driving role in how we deal with data and how we promote data exploration. So this is a slide that I think most people have seen similar versions of in the past. So this is my old deck, sorry. So you can see over here, this is an example from northwest Queensland, but the same thing happens across the entire sector. We're spending more money, we're drilling more, but we're not discovering as much. And the need is outpacing the discoveries. So from the example in northwest Queensland, you can see down here that we have a decline in discovery, an increase in depth of discovery. But up the top here, you see the research and work that's been done by the GSQ, but also by other academic institutions in the area. So there's been a massive increase in research over those times that we've had this decline in discoveries. And so there's some break, some discovery drought that's been caused by, we think, the suboptimal use of the data and the knowledge created from those high-quality scientific work we've been doing. So again, from the northwest, in the Northwest Mineral Province, Mount Isa, Cloncurry, large economic mineral resource for Queensland. New deposits are occurring at increased depths. They're in more difficult terrains and they're harder to find. And as exploration gets harder and deeper, the data becomes more valuable, and the pre-competitive data collected by both GA, GSQ, and old data locked in company reports and exploration data becomes more and more valuable. I was going to apologise to people and turn away if you care about data standards, but even though we talk about how important, how valuable our data is, this is how we store some of our data. So this is a photo from our exploration data centre in Brisbane. This is old tapes, this is CDs, this is DVDs, this is reports, stored in suboptimal conditions is probably the nicest way you could put this. So while there is a lot of value collected in this data, a lot of value in the actual acquisition of this data, there is no value left in the data because we aren't storing it optimally. You can't find it, you can't access it, you can't discover it. And so this is the problem that we see and we're trying to fix going forward. So coming forward to more recent times, data management before we launched QDX Data, and that's a product I'm going to talk about in a few minutes. We have our digital data held on NAS file shares or Samba file shares, some on external media, if we're lucky, on tapes, on hard drives, in paper reports. The location of the data, and we have raw data on tapes and disks that we might even not have ability to access data off those tapes anymore. One of the biggest problems is the knowledge of the data and where the data sits rested in the heads of only a few staff. And we had an institutional risk, both for the GSQ and for the prospectivity of Queensland, that if those staff moved on or weren't available, that we'd lose that access to the data, or lose where that data would be. We have a lack of consistent metadata to describe the provenance of those data objects as well. Coming on to data delivery and how we deal with delivering the data to the industry, because that's got to be that's our primary purpose, is enabling that exploration by having that data available. We do have a system. We had a system called QDX Reports, which has been in operation for about 20 years, but it had a 50 megabyte limit of data that could be delivered through that system. So we had no way to deliver no online way to deliver larger data sets. And the issue that we had there is we had experienced geoscientific staff who were spending their entire jobs bespoke processing data, creating DVDs, getting data packages, discovering data on our network, posting it, walking down to Australia Post and sending deliveries off to companies to enable that. And there was a lot of problems. There's a lot of problems with that. The biggest problems we have there, it was a fee-for-service point. So we had to charge back for the delivery of those media. We had a media cost recovery of when we're sending DVDs or hard drives, but the staff costs were massive as well. And the time from when someone would order data to getting data could be weeks, could be months if there was a large data order, or there wasn't staff that had that domain knowledge that were available to access that. And I'll give an example of my colleague Janelle. When Janelle started at the GSQ 8 years ago, 90% of her job was dealing with data requests. As a geophysicist, coming in to deal with data requests, so finding data on our network, creating packages, processing data up for people, and posting hard drives or DVDs of data off to clients. And that was a completely suboptimal use of her time, and we'll see as we step forward what happened with that. So we saw a lot of problems with our current data delivery systems and how we dealt with data. We had an invitation, a request for quote process in 2013 that ended up with Geosoft or Seequent, and I apologise, Nick, this is the old slide deck, and I did change the Seequent DAP server, launched in 2014. So QDX Data was launched 5 years ago now, and it's a Geosoft or Seequent DAP server that hosts over 20,000 data objects, about 3 terabytes worth of data in total. It's linked to our other data sets, including the QDX reports I mentioned before. So now the large data objects that relate to data in reports are now available for download, but also links to our Mines Online Maps, our GIS system as well. So it enables discovery of data through multiple platforms. It allows individuals and companies to access Queensland's geoscience data seamlessly, quickly, and free of charge. It's got an online catalogue, which is searchable. So the holdings on QDX Data has our airborne and ground geophysics, our HiMap and ASTA data, geochemistry, seismic data, downhole and wireline logs, mapping, and that's both current mapping and historical mapping in PDF or GeoTIFF forms, large data from reports that was not able to be downloaded before, and 3D models. Some of the advantages we see for GSQ itself is with DAP is we have a standard metadata or standardized metadata form in ISO metadata that means that all of our metadata is standardized, and that metadata can be extracted from our GSQ databases. So internally we have multiple databases that describe our data. So we have a metadata editor that creates the packages for DAP that goes in, extracts metadata from those objects and writes it to a new XML file that travels with the data as it's downloaded. So we don't have to rewrite and retype in that metadata, it's extracted from our in-house systems. We have data discovery from multiple different methods. So we have data discovery from the online portal, We have data discovery via direct links from our other systems, our Mines Online Maps or our online GIS systems or our report system. And there are APIs that plug in there. And I'm going to talk about those as well in a second. You can do a combination of metadata and spatial queries to find data. You have a crop, zip, and ship functionality, and you can change formats of data on the fly for select data types. The Seeker tool plugin, which again I'll talk about in a second, but really the most important object and the most important feature for DAP for GSQ is that self-serve data discovery and download. So to come back to my example before with Janelle, once we launched QDX Data and we updated and created all the objects in DAP, our requests for data went down so far that Janelle's now completed a PhD working on magnetotelluric data and has now moved on and is now creating new data sets. So it's not about dealing with data requests and data discovery on the point there. Now we can value add data, we can acquire new data to support exploration and move forward and have this self-serve discovery enabled. So a bit of a plug for those that may have seen QDX Data or may have used QDX Data in the past. We've had a new update just happened in the last month to QDX Data, which involved a whole back-end database version change. A new screen at the start so you can define an area of interest and queries to reduce the results and get to the data you're looking for straight away. We can bring in spatial layers from web map services or web feature services, so from our online GIS, and you can bring in your tenure or your geological domains into the map to understand what data sits in the areas that you are interested in. You can share maps as preloaded links or data, so you can email colleagues with a pre-created link that will then open up a package in QDX Data in DAP that will go straight to the map area that you're looking at with all the layers turned on that you're looking at, which is great for serving clients when they have questions about how to access data. You can actually give them a link straight into that data, or as GeoTIFF images. And there's some simple GIS tools, transparency and annotations that can enable better discovery and better sharing of maps. So the Seeker tool is one of the things I find is most important and most exciting about QDX Data. So that allows our clients using other tools, ArcGIS, MapInfo, or Oasis Montage or Oasis Montage the viewer, to access the DAP service directly and bring data straight into their own projects on the fly. So I've got an example of that running through here, if it loads, which looks like it is. So I've got an ArcMap project on a non-departmental computer here. I'm looking at a particular area down the Southern Thompson on the New South Wales border, and I'm querying live on the DAP data in that area. So it's brought up all the data that's in DAP currently in that area, and then I can define where I want to download that to my computer. I can change the resolution, or I can crop the areas. And then you can see it's coming straight into my ArcGIS project on the fly, and I can work on it straight away, as well as sitting there on my machine. So I have the data on my machine, but I also can get it streamed straight into my application to start working on the data on the fly. And from where we had weeks or months to access data, to getting data basically instantaneously, and I did speed up that video a bit. I don't work that fast. It would be great. It's a massive step change in how we get data to our clients and how people can interact with our data going forward. So that's where we've been. That's what we've been doing over the past 150 years, but really the past 5 or 6 years, we've been working with DAP and growing our holdings in QDX Data, but also trying to push the limits of what we can do with QDX Data. Now I'm going to talk a bit about our current state and our future at the GSQ. And I guess my talk was about open and fair data, and that's where we're really striving for with Queensland. But as we go forward, I just wanted to define those concepts a bit. So open data, I think we all talk about data, open data. Queensland, all the governments, I think, have an open data policy about sharing data and making sure that data is available. But we want to go one step further, and we want to look at fair data. So when I talk about fair data, I'm talking about data that is not just open, but is findable, accessible, interoperable, and reusable. As a survey, our data is not always open. We have confidential reports. We have confidentiality periods that are different across different commodity groups, but some of our data comes into us confidential for a period of time that might be years to end of tenure. And so open data doesn't really work for that, but FAIR does. So we want to make sure that our data is findable, both by humans and by machines. And I think the machines part going forward is going to be more and more important. While the data is findable, we make sure it's accessible, so we can get data to clients, or people can access our data. We want to make sure the data is interoperable. So we want standard open data formats delivered by web services that mean that people can access the data and do new things with the data, and reusable. So we need metadata about provenance of data and about the use of data, also with machine-readable concepts that means that data can be reused for different purposes than what it was originally created for. And I guess the other side of that is the FAIR data isn't really just an idealistic acronym. We believe FAIR data will result in better outcomes in both time and money for both GSQ and the exploration industry, reducing time to find, clean, and organise data. This is an image from Forbes magazine about what data scientists spend most of their time doing. And you can see the two biggest chunks are really cleaning and organising the data and finding the data. So if we can reduce the time needed to clean those data sets, to find those data sets, then we can enable better work and more work to be done with that data. While this is for data science, we think the same thing occurs in geoscience, that finding and discovering the data is the longest time, and actually working with the data is the hardest thing. I'm going to whip through a bit faster because I've been going too slow, apparently. So the GSQ's vision is to be an enabler of disruptive innovation and collaboration in the mining sector, and we want to be a leading provider and custodian of geoscience intelligence, insight and knowledge in the state. And what I really want to talk about here is this state that we're calling data-driven exploration, which is where we see our future being. The Geoscience Modernisation Program is a program we've started at the GSQ, looking to acknowledge the fact that our online data, our offerings are not adequate to enable industry success, and we're looking to go to a new system, a new place where our technologies, processes and systems are optimised to enable better discovery, better efficiencies. So the data-driven exploration really has four main pillars. So we're talking about data input, so we're reforming our ingested data, how we request data to be reported on, looking at confidentiality in that. We have the data curation, which is where this GDMP, Geoscience Data Modernisation Program, fits in. We have value add, and that might be GSQ-led, or that might be APIs that can plug into our data lake solution. And then at the end, we have our industry engagement. So that's the skills collaboration, the skills sharing space. So coming into the data lake, we're bringing all of our data into an Amazon Web Services S3 data lake. So that brings all of our data into the cloud and enables, we think, new ways to deal with the data and new ways to build that. The data lake is built for a data object store, so all of our data are data held in the cloud. On top of that, we have a data catalog that indexes all of our digital collections, but also all of the physical data that we might hold as core or pulps or reports, all those seismic tapes that we haven't transcribed yet, and all be catalogued. We then have ways for data to access, both human and computer and cloud-based access. We have processing that might be QA, QC on top of those to look at new key value pairs or new understandings about our data. We have visualization tools that are going to plug in to enable spatial searching or new graph-based searching or textual-based searching of that data. We're looking at analytics and machine learning on top of that. And this is a long process. This isn't going to happen in the next 2 years or 3 years. This is a process that's going to take a long time as we upgrade our entire ecosystem of data. But really, the data lake has three concepts. We're bringing the data in, we're ingesting the data better, we're storing it better, and we're hopefully making it extractable, easy to extract and easy to analyze and do visualizations and analytics on. So coming to the data catalog, and this is really pivotal to the data lake. The catalog provides us with most of these key capabilities. We're looking at standardized data schemas and metadata schemas. We're looking to bring controlled vocabularies to how we describe our data and our data ontology to make sure that what we're calling certain objects, we know what that means and we can describe that. We're looking at having persistent identifiers of that data, so as data changes and moves, we can keep access to that data. And linked data, so we can look at relationships between data in that space. We have had an industry portal release. There's a URL down the bottom there, focused really just on the export of data. We've got 12 terabytes of seismic data and our geochemistry database, the state of Queensland, in the data lake there. We have a Seequent portal, web portal on top of that enables discovery of that data. But it is really just that extract portion of the space at the moment. We're building our ontologies, we're building our vocabularies, and we're looking to bring a vendor in to build this data lake in the near form to start this process of building this. And again, it's going to be a long process for us. Again, I've lost a slide here, but that's all right. We see the opportunity statement for the GSQ to optimize the geoscience data ecosystem, to unlock the value of data, and to enable exploration success. And we see tools like the data lake, we see tools like DAP that are really in that space to help us take that next step to enable new discoveries and new ways to work with our data. Thank you.
Thanks a lot, Matt, for providing that insight and flying to Brisbane for that. We really appreciate it. We do have time for a few questions, so if anyone has any. Sure. Neville, the front.
Yeah. Just, you mentioned the concept of cleaning takes a long time.
Yep.
And I think one of the biggest problems in the industry that internally and external is we as industry don't like to hand over data until it's clean. One of the biggest things about exploration is the first thing is just knowing data is there.
Yep.
So what are your thoughts and comments about releasing data in its natural, unorganised, dirty, unclean state and letting people deal with how they want, because it's better than not having it, is my view.
I agree. I think it's a spectrum of that. I think we're going to have data coming in multiple different levels of cleanliness. And we need to have that provenance information in the metadata to describe that, describe the quality of data, describe where the data's come from. We've had discussions with companies as well that know that they have taken our geochemical database and spent the last 2 years on cleaning it, editing it, changing it, and they're looking to bring that data back into it. So we have the raw data that is our point of truth, if you will, but then we have the clean data as another version of that data that people can access. So looking at having multiple versions of data, and you need to control that by your metadata standards. So I think that's somewhere we've got to go. It's better to have some data than no data at all, but we want to have the cleanest data as possible. We're not going to spend time to cleaning data and holding data until it's perfect, but we want to have the best quality data we can enable.
Thanks, Neville. Any other questions? Sure, at the back there. Just wait for the mic.
Yeah, hi. I mean, I've heard the talk about the data lake, but is the data lake as simple as DAP running on Amazon Web Service, or is it more that there are data objects and XML tags and you've got the ability to use whatever AI or machine learning technique you want on those XML tags?
Look, I think that the data lake is more than just DAP running on Amazon Web Services. I think DAP running on Amazon Web Services, and that's where I want to keep pushing at, is going to be important. But I think the data lake is a whole ecosystem. The DAP controls some level of visualization of extract, but we're going to have a complete ecosystem change in how we ingress the data into the data lake, how we store it, be it structured data or unstructured data or semi-structured data, and then how we run those processes and analytics on it to hopefully create new insights in that data. But I think it is more than just having a massive pile of data and saying find the data in there. We've got to have more on that than that, just DAP. Yep.
Thanks a lot, Matt. We really appreciate it.
Thank you.
Give a round of applause for Matt.